Hello, this is Chris Cohn and Zain Ali from Minter Graphics, and we're going to just provide some commentary on this video, which guides you through the schematic-driven layout, simulation, and implementation, and actually post-layout verification portion of this course. So you can either use your existing project or create a new project, and if you open up the virtual labs, what you should see is the eBeam PDK has been updated, and it's been updated to include this cell library SDL container, which has full flow driven cells. Not all of them are full flow, just a fair warning, we'll update these later on. But it does have enough cells and components in here for you to create an interferometer design. So one of the things you can do is just take a look at the eBeam Y1550, the Y branch, and you can actually see, for example, the marking layers that are required in order for Calibre to extract this model and the connections. And so there's a DevRec and PinRec layer, and those define the boundary, and then the text of those layers actually defines the name. So DevRec text defines the DevRec name, PinRec text defines the PinRec name. So it's pretty straightforward. So you can go ahead and close that. And then what you want to do is create a new library. In this case, it's SDL Flow. And in that library, create your new schematic. So, and then use your symbol selector, and then go down and browse to the cell library SDL and start placing components from that SDL, or from that, from that container. So you can pick whichever grading coupler you want. You can add in the Y branches. As you move and place these things, there's hotkeys like R to rotate and F to flip. If you overlap the pins and then stretch one of the devices out, it actually creates the connections automatically for you. Use the W hotkey in order to draw wires. And then I'll be sure to define the interface. In this case, there's pins on these called, on the grading couplers, called op fiber. And you can select those and name them using the hotkey L to specify the name. And then once they're named, you can actually place a port. And we place a bidirectional port by convention. Oh, and I forgot, you need to go ahead and define the unbalanced waveguides. And so you can add the waveguides from the eBeam library. I think it's WG strip 1550. And then I think we changed the property on one of them to be 200 microns. So once you're done with that, you can do a check and save, close the report window, unless there's some errors you have to fix. And then you can generate your symbol. And then here you can go in and customize your symbol. In this case, we'll just specify opt A to be on the right and opt B to be on the left. Doesn't matter. You can do it however you like. You OK that, that's your symbol. And we can go ahead and just check and save that and then close it. And then we can move on to the next portion. And what we want to do is actually create your simulation test bench. And so here, we'll just call it TB underbar interferometer. And then when we create the schematic, we can go back to the symbol selector and then add in the interferometer we just created the step before. Draw some wires on the two pins and then do a check and save. And then you can press the play button, and the play button puts you into simulation mode. You can specify the interconnect simulator. This is important. Be sure when you run interconnect to go to the viewer, or actually to set up environment, and then turn off the no include option. This allows you to pass post layout extracted netlist to interconnect to run a simulation. Then you can set up your O&A analysis. Just use the video as a example. Change your range to 2000 e to the 9. Press OK and run, and you should be able to quickly see the result. An EasyWave, our waveform viewer. And so just go ahead and plot that. And then, by the way, you can go back to your schematic, change some properties, and then rerun your simulation using the R hotkey. And then when you get the results, you can overlay those results and view them together. And so that's the end of this, video. Again, this is Chris Cohn and Zain Ali from Minter Graphics. Thanks for your attention, and please let us know if you have any questions or any comments.